All right, so I want to switch gears a little bit. I'm going to go back to thinking about some of the directions we're moving in health. And the original plan today was to have sort of a panel of people who are doing practical work on network interventions and experiments. And thankfully, Manoj is here to provide us some insight into how this is actually done. Ronnie was not able to join. What's Ronnie's last name again? Chatterjee, who does some remarkable work on entrepreneurial network interventions here at Duke. So we have other people in our literature, but that's a long story. Anyway, I've been talking too much. It's been a long week. So what I thought I would do just briefly is give 10, 15 minutes tops of sort of overview of what network experiments and interventions look like, sort of point you to some key papers that have been coming out recently in the literature, and then turn it over to Manoj to talk about some of the things that are really practical and really describe what I think is just a truly remarkable data collection effort they're engaged in the process of doing a network and health intervention. So the first thing, of course, is to think about why we might care about doing experiments at all, and it harkens back to this problem that we touched on last a couple days ago now about causal inference and peer influence models. And the problem is that they're generally confounded if there's some unobserved latent variable that's moving through the network, and there are really only two ways to get around this. And that's either to have some observed variable that soaks up all of the variance that's coming out of your latent variable, which says effectively that you have a well-specified model and nothing on the outside, or you have some variable that you're able to intervene between the latent variable and the pi functions to generate it. And it turns out that's what a network experiment is. So if I can randomly assign you to being in treatment or control, or to be connected or not, then I can generate this by experiment and break this link, right? And so in our other way of thinking about this language is that you can think about this, I thought I had another slide there. Anyway, you can think about this from the peer influence standpoint as either affecting the network or affecting the exposure, right? So on the one hand, I have the pattern of ties that people are connected to. On the other hand, I have what's flowing through those ties. And network experiments have dealt with either one. We just, as a way of thinking about this, we think about this idea of network exposures through the weight matrix. That's what that little W is. How's that not there? Anyway. And so the pieces that probably kicked off this literature, and maybe Manoj, you might chime in if there are some other pieces. But the original work that really got a lot of attention was these works for roommate studies in Dartmouth. And so the classic problem is if I'm selecting my friends because they're sort of nice, fun partiers, and I like hanging out with nice, fun partiers, then the fact that they also smoke and I smoke doesn't really explain much. It's all selection and not influence. So it would be really great if we had some kind of a social relation that was manipulated at random, that was truly exogenous. And it turns out that at Dartmouth, and like a lot of colleges at least used to do, I don't think this is true anymore, they used to randomly assign you a roommate. So at Dartmouth, what they would do is you would fill out a survey that said, do you like to have your music on when you study? Are you generally messy? And do you smoke? Those were the three variables that they had. And so within those three variables, so you had those 9 possibilities within each of those possibilities, you were randomly shuffled, and your gender, thank you. You were randomly sorted. So it was random roommate assignments. And what that meant then is that you could think about something like my GPA, like I's GPA, as a function of my own academic behavior, so how smart I am according to SAT scores and such, and the academic behavior of my peers. This randomly assigned roommate that was is with me, and that allows me then to have a connection. This coefficient then is the effect of my roommates' academic success on me, independent of any of my selection, because I've been exposed to them at random. And the beauty is they find relatively consistent effects. So you can do it for academic effects or what have you. In this case, it turns out that my roommate's GPA has an effect on my own freshman year GPA. Goes away by the time I'm a senior once I've changed and had time to select my own roommates and sort of changed over time. But you find a consistent, if not perhaps overwhelming effect, and you find it as well in some other ways of breaking up the functional forms. So here you're looking at the top 25% or not. So it's a very nice a way of explaining some of these events. And so once this ball got rolling, people started looking for ways to do it in lots of different places. And so you can look at deviant peer experiments. This is a really fun one where they took people in essentially a lab setting, lied to them, told them they were doing a memory test, and had a confederate say, I'm going to cheat, why don't you cheat with me? And they're able to show that people will, in fact, if they're in the treatment, they will cheat while those who are in the control did not. Right? So there's a clear lead you astray effect in that lab setting. And there's lots of other ways in which this has been done, where you've tried to differentially expose people to peers, right, into what they're doing. So this is another case where they're studying inequality in an artificial music market. And so what you see on the peer influence side is manipulated by the experimenter. And this is the first piece that Dawes, Watson, Salganic put out. Another example that people have done is that they've, under the hood, they've changed the network that you're exposed to and how they're exposed to each other, and ego never sees it, right? So there's an underlying network effect because it's an online experiment. And in some cases, the experimenters make it so that your neighbors are connected to each other, you get lots of redundancy. In other cases, ego is connected to people who aren't connected to each other. Now, this is an effect then, so if there's a difference between being active in this version and this version, it has to be due to the network because whether or not you're in this condition or not is purely random. And moreover, you don't know it. There's no signal. You don't know what's going on. You just have the effect coming through the set. So that's another nice way to show that in this case that adoption of the behavior is different in the clustered network than in the unclustered network. And I have a few of these different kind of examples here in the piece. Now, one of the problems with these kinds of studies is that there's a difference between the treatment effect and sort of the average treatment effect, the things you measure, and the things that you're actually picking up when the people who treated, the treatment among the treated, if you will. And you can think of it this way, that we have some exposure that's coming through from the network. This is all work from Sharik Hassan, which is just really pretty. And you can imagine that I randomly assign you to roommates. That's what this XJT sort of effector is. But I might not like you as a roommate, right? So I avoid going to my room. I don't pick it up. I don't take up the behavior. And so if that's the case, then we have to intervene a second sort of piece, which is the likelihood that I'm actually going to take up the behavior, right? And that is, so the effect of my altered behavior is only there if this is there, right? And so we can have a second function which describes the probability that I'm going to take up and pay attention to this effect. So there is what happens is there's another selection layer that goes inside of these experimental effects. And the effect of this at the end of the day, and this is what makes this paper so nice, is that you can then, once you specify this model, you can play some games and ask, well, depending on how big different versions of these coefficients that go into this selection model are, what does that do to the actual treatment effect that's there that we might observe and measure compared to what should be there? And so it turns out that these things routinely lower the observed effect. Right? And so where you might think what you're doing is seeing an average treatment, a real treatment effect of, say, a coefficient of 0.1, what you see across the entire population, if people only hang out with other smarter people, if they only are willing to learn from people who are smarter than them as opposed to people who are dumber than them, there's no effect of having a roommate that's dumber than you, and there's a lot of effect of having a roommate that's smarter than you. If that's the case, then the average treatment effect is going to look a lot lower than it really is, right? Because these people essentially were never exposed to the interaction because I decided to opt out of it. And so differential opting out of the experimental effects can make what look like purely exogenous features relatively lower effects than they are in reality. And so this is another way of thinking about, this is a fun example here, where people, if the peer trait is the amount of variability in the peer network. And so you only get some effect. If everyone's exactly like you or very different from you, you get no effect. But if they're in the middle range, you get some effect. Right? So there's some nice, so I'm not going to listen to people who are exactly like me. And the beauty of this work that Sharik is doing is that he has a lot of different of these kinds of situations, and he's able to show in real data how likely you are to have an effect, whether people, depending on what kind of features are drawn into the selection equation. Again, I don't want to go into the details of what this is. It's not the point. The idea is that these experimental effects for peer influence are probably underestimates because because not everyone's actually a peer in the way that you might think they would be. Just because the kinds of relations that I can randomly assign you to are probably not relations you care about deeply, right? And so you have to it only works for the people you care about. Now, the other way of thinking about interventions is that we don't try to manipulate the network. We leave the network alone, but we pick different people in the network to do something too. And so we give them a bit of information, or we play with them in various ways. And Tom Valente has a wonderful review paper in Science that came out about 2 years ago, where he walks through the various and sundry ways that health researchers have done this. And he says that most of the work falls into these 4 different kinds of features. You might try to identify like opinion leaders, for example, or flow blockers. Or you might segment the network into clusters so that you can do a treatment in one set and let the other be control. Or you might try to highlight certain kinds of relations, such as those that cross groups. Or you might try to reorganize the network by providing ways in which people can hang out to each other. But each of these, and he provides a nice literature review to go through and think about the different kinds of ways when this is successful and when it's not successful and so forth. But they're all different strategies that one might apply to working on the network. And this has probably been the best example of this in the recent literature is this paper Bonjuri et al., where they're looking at the diffusion of microfinance tools, and they're able to show that there's a nice effect of effectively what we would call Bonas's centrality in our world, or eigenvector centrality, on your likelihood of having participated in the outcome. And so it's a really nice series of papers where they interject a bit of information into people. You can differentially associate how much, where they sit in the network, and see a different effect in the uptake. And that's the kind of projects that people are engaging in more and more. A lot of these in the slides, and I just wanted to give a flavor of the kind of things that are out there before we move on to the example. Question, please.
Have you, this is a question I had a few days ago, but have you ever seen where people have looked at unintended network effects of interventions, like let's say an individual level intervention, and just seeing how much it may or may not have spread?
Yeah, so we're actually engaged in a big study of effectively unintended network effects, which is with the Prosper study. So the Prosper study was a peer intervention study where it was the logic of the study was a peer influence logic, and what they were trying to do is teach kids resistance skills. I'd say, like, if your friends tell you you're going to jump off the cliff, you don't have to. Those kinds of. And there's a series of different stories, and they happen in different schools, and this is what the intervention was. And the treatments were done both school to school, so some schools are treatment schools, some schools are not treatment schools, but also within schools, some families got an in-home treatment and others didn't at random. And then this is the study where we realized they had a blank page, so we said, let us add a network questionnaire to it. We did, and so we were able to go back and see what happens to the networks. And it turns out that over time, the kids who got the family treatment, if your returns to delinquency in those settings dropped dramatically. So in the untreated settings, delinquent kids remained popular. In the treating settings, the delinquent kids became less popular. And so this wasn't a study that set out to say, let's make kids less popular, but it had that effect, right? Because the things that generated popularity were actively told to be ignored, and most kids took it up. So these kinds of things do happen. I think that people haven't spent much time thinking about it deliberately, but I think people have sort of stumbled across these effects from time to time. There's another great, there's a lot of work being done on natural experiments. There's a really nice paper that looks at social media effects and who you can interact with around hurricanes. And so you follow the path of the hurricane. You can see which county or which area gets hit by the hurricane, which area does not. And you can see that if you're about to get hit by a hurricane, you sort of close ranks in your friendship ties and who you're texting and who you're talking with. And as soon as it leaves, you should open up again. So you can see how communication networks are affected by the environment, and it's purely exogenous, so those are kind of nice. They tend not to be long-lasting. They're just around the event. Okay. Raj, want to take a shot?
Thanks so much, Jim, for having me here. And a couple of you, at least in this room, have heard parts of what I'm about to say at least about 3 times now. So if you want to get up and leave, go get coffee, please feel free. And even others who haven't heard it, if you leave, I wouldn't feel bad at all. So this is what happens when you come in to talk after having finished teaching all semester long, where you're used to seeing students fall asleep in your class. And when we decided when Jim sent me the schedule and I saw that we were meeting after lunch, I said, yeah, not again. So hope you guys have got plenty of coffee. And all right. So this is work that is part of a much larger project, but given the subject interest for this workshop, I'll skip most of what we are talking about in the overall project and focus only on the network piece. And this piece is what we are collaborating with Jim, of course, and Kendall, who's also from our research team, is here. And then there are other collaborators from the World Bank and UNC and Stanford. Actually, Aaron's paper on microfinance was the one that you just saw last as well. And so what are we doing? The brief background is so brief, I don't even have text on it. So I'll skip all of the stuff that I would have told you if this was a different seminar with one sentence. Is we are looking at governance types of interventions where the government is introducing information and community level participation interventions to make service delivery better. And the reason is because people don't show up to work, people don't do what they're supposed to do, and so the idea is if you can take the responsibility of accountability to the end users, maybe things would get better. They've tried it before in small, tiny little, very, very micromanaged settings and found massive effects. So the setting where we are working in, the government said, let's try it, and try it out as a policy experiment on a massive scale and see if it works. So while they're doing that, we said, well, it would be nice if it did work, and we are doing a big evaluation. But as part of that, we wanted to study a few key research hypotheses. So given that every single person in this room knows infinitely more about networks than I do at this point, whenever it comes to anything technical, and if you raise your hand, I'm going to let Jim answer the question. Better still, whenever we mention anything technical here, I'll shut up and let Jim talk about it as well. So that will spare me the embarrassment. Okay. So the research questions, actually, I should point out to you, when we designed this study and got started about 4 years ago, social networks was not something we were thinking about. It's really as we started digging into the sort of underlying mechanisms that we started worrying about, did we realize that actually this is a question that we were ill-equipped to answer. And that's where we started talking with Jim and realized this is actually something we could do a lot with the networks data. So, the two main questions that we wanted to focus on, given that this is an intervention where the government was trying to get information out and get people involved in trying to hold service delivery folks accountable, the first one was about information diffusion. Right? You go out and give information to people. It cannot live in a vacuum. It needs to spread around. So if the government, tomorrow if these projects work on the pilot, still pilot is about 270,000 people we are talking about. No. 230 million. I'm getting the number. Yeah, 230 million. Right. Anyway, it's massive. So even in that pilot, if it works out, the question is if you want to scale it up countrywide, how do you do it? So the first thing we want to study is the broadcast strategy, which is one option would be to send information out through phones, IVRs, where everyone gets this big broadcast message every month saying so-and-so activity is happening, this is important to your community, be part of it. But as most of us who receive text messages on the phone know, after a while we just tune out. So even if we're still trying to pilot this out to see how we can make this more effective, but there are at least two other alternatives. In our discussions with the government, when we tell them about spreading information, the first thing they'll tell us is, why bother? We have this big, massive machinery of government representatives down to the village level. All I need to do is pick up the phone and call them, and it's done. So of course, we tend to laugh at that strategy. But the truth is, it might work. Who knows? So we want to test that. And the third alternative to that is using networks. Every single village, no matter where we are, has existing social networks. So if we can work with those network seeds to try to disseminate information, does it do better or worse? That's really one question that we want to ask. And once we do that, then we can identify optimal strategies for information dissemination for policy objectives. Right? So this is very different than saying, should Coca-Cola use method A to spread information about the new product on the market? It's slightly different because it's much more sustained. It's oftentimes about a public good that people are not really all that interested in, and so on and so forth. The second one, which gets much more trickier because this is where behavior comes in, is about the should I go or should I stay kind of question. And the idea is collective action problem by definition means that I am going to be less likely to participate than if it were my own problem. And so the idea here is that we want to understand the individual's decision to participate in an activity that's going to benefit the whole community. The problem that we started stumbling upon was the following, that participation is really a function of multiple things, but at least in this context, first, it's a function of how much information exists in my network, right? So is it really true that if people in my network knew more about it and were more concerned about it, am I more likely to go? So it's just sort of some measure of information flooding my network. And the second related thing to that is, if people within my network start participating, am I more likely to go? So you can easily imagine that there might be some threshold effects, right? If there's none of my friends want to go for a dinner that's being organized, then I might say, well, maybe it's not good, I don't want to go. On the other hand, if every single person wants to go, I might start thinking, well, it's going to be too crowded, maybe I shouldn't go. And this is a dinner that I might actually benefit from. Right? Imagine when the stakes are much lower, and this is a communal collective action type of problem, you can imagine that threshold effects and free riding effects are going to be much more severe in this case. The problem, as Jim alluded to earlier in his talk, endogeneity. Whether people share information, whether you as my friend decide to go is also a function of whether you think I'm going to go, right? So it's very difficult to disentangle these effects in this setting. Of course, all of you know much more about this than I do. So what we did was tried to do the best we can given this setting. The setting is pretty unique, so maybe a couple of words about what we did. As part of this big study that I described to you, we convinced the state government to give us 120 villages, which have, each village has roughly about 400 households in there. We broke into 3 different arms, and we're focusing on 80 of these villages, right? So about 32,000 households is roughly what we're talking about. And there, we will be testing out all these interventions on a monthly basis. We'll be doing repeated monthly experiments and collecting high volume data through phone calls, IVRs and stuff like that. IVR is an interactive voice response type of setting. So we basically can send information out, see what happens to the information. Send information out, see how people change behavior in a very rapid, high frequency type of manner. And the idea is, first what we did is we went about surveying every single one of the households and found out from these households whom they spend time with, whom they borrow money from, and whom they talk to if they need a health-related piece of advice, or whom they get information from about health-related stuff. And once we had uniquely identified every single household, actually it's more household member, but for our purposes we are working as if it's a unitary model of the household. So every household with cell phone numbers, we linked it to their households, and then tried to figure out what the network looked like. And so this is stuff that Jim actually did a lot of work with, and let me see if I can get this working. That's one, and that's the other. So these are examples of 2 villages. One of them is this one is a relatively smaller village, and as you can see the network characteristics, and Jim, you might want to tell them about.
Yeah, so this is these are just 2 sample villages that we pulled from the others.
Oops, sorry.
Just go back to where it's at there. And this is a visualization where we use the export to SVG from Payak that I was just showing you. And one of the nice things is that this is a multi-relational network, so instead of just being tied or not, we have some ties are health, some are finance, some are free time, and it's interactive. So if you uncheck one of those, you can say that's the free time network, or this is the health network. So if you click 3 and get rid of free time, you see those are the people who talk to each other about health-related issues, right? And the finance are the people who trade things. We've used the label hover function to figure out essentially which, because we figured this would be a sample drawing thing, we might want to think a little bit about this and use it as a way to play some games. So if you hover over a node, then the EID comes up and so forth. Here, please.
So when you did the community detection for this network, did you do it on the multi-layered network of all 3 types of ties, or did you choose one and then?
I pooled them, and I treated it as a strength. So the more relations, I summed them essentially, right? In the back.
I was just wondering, the cell phones are linked to health or free time or
No, the cell phone numbers are like an ID, right? The reason why we want cell phones is when I'll start telling you about the experiments that we'll be doing, I'll be sending out information to a cell phone, right? So if I send, all I need to know about you is your unique ID, and there's a cell phone in the background that my data collection firm is sending information to. Does that make sense?
Wait, if you're going to talk all about it, I'm waiting.
Okay. Sorry, Jim. The ties, you mean to say? Oh no, so we had to do it iteratively. So for stage 1, what we did is we went out and did a full census of every single person in the village, and then created these 2 lists. One was alphabetical by first name, one was alphabetical by household name, and then went back to the same households and say, all right, household number 1, who are your friends you hang out with, and as they start listing people, you go check. And then all that data gets entered into an Excel database, and then we bring it to Jim, who does fancy stuff with it.
This is the pilot.
Right.
This is remarkable data. In fact.
Sorry, go ahead.
During the pilot, are you finding much crossover migration or contamination between your areas, or
No, this is spread over a very large area. Right. There is a lot of migration in this state, but it's migration from this state to the capital city of Delhi or to Bombay or other places. Within village, migration is relatively low, unless it's like a marriage or something like that. But that could happen. The thing is, this is happening close to real time. So this is data which was collected 7 months ago, 7 months ago or so. And then as we speak, the training that I'm going to tell you about, it started yesterday. It's finishing today, and they're hitting the ground with the interventions starting July 4th, when we'll be going to the field. So it's happening in short enough period of time that I'm not so worried about migration. But in the long run, yes, absolutely. Go ahead.
Did you consider any measures of social capital in the village, in the two arms?
Yes.
Because you can imagine if there's high social capital, then the intervention going through a person
Right.
might be more effective.
Right. So we did. In these villages, every single one of the villages, there are 20 households that were randomly sampled, where we did the full detailed socioeconomic status and household survey and health indicators and everything. But that we had to do it in a sample because we weren't sure where this is going at this point. When we go back for the follow-up, we might want to collect a lot more detailed data at that point in time from a wider, 32,000 households is a lot to survey in this case. Okay. All right. So that's what our data looks like. So let me tell you what I'm trying to do. This is a lot of information. I unfortunately did not spend time making nice little charts. You can ignore all of that, and I'll tell you what's in there. Of course, if you want to hold me accountable as I speak, you're welcome to read it, but feel free to ignore. So what we are trying to do here is, first we'll be doing the network seeds versus government seeds versus broadcast message type of stuff. So remember that we have 80 villages in all. So we have 20 villages. And in each of the villages, first what we do is we send out, in the first month, we test the theory about, we test the hypothesis that sending information through network seeds is better than doing a broadcast message to everyone. And you might wonder what a broadcast message looks like. This is an example of, is there audio here?
It's not plugged in.
It's okay, never mind. It's a very tacky message, a 30-second message with music in the background with this radio announcer saying, in Hindi of course, that, greetings, this is a message coming to you from Duke University and its researchers, and we are doing this study to help provide you information about stuff that's happening in your village. By the way, do you know that this event is scheduled to happen next month? Press 1 if you think yes, or no if you don't, and so on and so forth. So what we do is we send out the broadcast message to everybody in these arms. You can ignore the info and facilitation. That's the stuff I have not told you about. And then the other half of the villages, what they get is information that goes out only to the network seeds. So 10 people who are selected based on measures of eigenvector centrality, or in our case, because we want replicability, we are using what we are calling the gossip strategy. That is, we measured eigenvector centrality, but we also asked questions about who are the people who are best at spreading information in the village as part of our household surveys. And the 10 people who are ranked highest through that method are the ones that we'll be working with for this part of the intervention. So in the first, we send out information to everybody. At the end of the month, we again call everyone back and we ask them, hey, did you get this information? So let's say Kendall was the one who was, we called up as part of our network seed strategy and gave her all the information. And Jim and I are friends. End of the month, Jim and I both received calls from our research team to say, did you hear about this information? And because we're doing this for every single person, we can actually figure out whether information given to the network seeds in these villages does a better job at disseminating information. And simultaneously, we also know these community collective action events are happening in these villages, the meetings that I mentioned about. And so we can test whether villages that were randomized to receive the different information strategies have a better participation or better performance in terms of participation in these meetings or not. And so then we do that in the first month with the network seeds, and the second month we do the government seeds as well. And the idea is here, this is what the government would ideally like to do, so we can then show them, here's what happens when you work with your 10 folks, here's what happens when you work with the network central people, and here's what happens when you just send out information to everyone. And in case you're wondering, sending out information to everyone is very, very, very cheap, because the cost of sending out a text message is close to nothing in these areas. Is there anything else around this? No, and one other quick thing, just to sort of be hyper careful about what we are doing. What we will be doing is, even in the areas where we send only the network strategy, that is, the broadcast strategy where we send information to everyone, we randomly pick 10 people in the village, because you want to be able to measure the effect of sending information to the network central person relative to 10 random people. Right? It's entirely possible that because I have, Kendall calls up 10 people and talks to them, explains to them, that itself might have an effect, versus them being the network central individuals and stuff. So we can measure all of that stuff in this case. Then what we do, is there something else that I need to add? No, okay. All right. And then what we do is this collective action stuff. This is where things get a little more hairy. Because what we want to worry about are two things. One is the effect of information diffusion within my network on my decision. And the second is the effect of my network's participation, right? There's also problems around common knowledge, right? So if Jim is planning to go for this nice collective action to make society better, and I'm trying to make my decision based on whether he goes, two things have to happen. One is I need to know whether he's going, but I also need to know whether he knows that I'm going to do what I'm going to do or not, right? So this common knowledge problem exists in this setting. And so we're going to try to deal with that. I'll skip this part and just tell you about the experiment. So what we do is, with all of that network data that you saw, so essentially what we do is we start with assigning villages to some number psi, which is basically the percentage of village households that will be randomized to receive a visit from our team. Right? So think of a village that's assigned to get 20% of the households are randomly going to be selected to be visited. So far we haven't said anything about the network. In another village, 50% of the households, or let's say even another village, 20% of the households are also selected. But it's 20% of individuals or individual households that are being selected at random. So within the same village, where 20% are selected, if Kendall and I are residents of the village, she might, just by chance, it might happen that 40% of her network gets visited and 60% of my network gets visited, right? So by randomly assigning the psi to villages, we end up having incredible amount of variation in what share of each individual person's network is selected for being visited in this case, right? So then what we do is, first we send this common information to everybody, and then these households receive a visit. And during the visit, we tell them that, hey, listen, there's a meeting happening. Remember the call that you received or the information you received on your cell phones. There's this meeting happening. Here's the agenda. Here's how important it is. I hope you will come, right? So what we've done is now 20% of my network has been informed about this meeting, and hopefully they'll show up. And 30% of Kendall's network has been informed, and hopefully they'll show up. And then we get to see two things. Villages that have more, villages where a higher share of households have received visits, do we see that they actually start participating or not? But more interestingly, what I can then see is two things. I can see whether when more information was spread out, or rather, when information was spread to bigger shares of my network, do I get that information? And now I can do something better. I can go beyond asking simply yes or no. I can start thinking about quality of information, right? So I can ask some qualitative data about the information that's being spread, because if it's just a matter of here's a meeting that's happening, that's very different than saying, can you tell me about something that's really valuable to society or to our community? And then it might happen that as we start spreading more information, people start talking about it more and sharing more of this information. So we get to measure that here. The second thing that happens once we get to the month 4 is we introduce common knowledge. That is, this time when I go to Jim's house and say, hey Jim, remember this meeting was happening and I hope you will come. By the way, in addition to going to your house, I'm also going to go to your friend Kendall's house and tell her that this is happening, right? Now, for a second, just imagine that Giovanna and Giovanna is friends with me and Kendall, but not with Jim. In that case, what would happen is when I go to Giovanna's house, I tell Giovanna that we are visiting her, but I'm also visiting me and Kendall. And when I go to Kendall's house, now I'll have to tell Kendall that you're visiting her, but you're also visiting Jim and me and Giovanna. So what we do is essentially create a spreadsheet for every single household, where based on this underlying randomization, our enumerators go to every single household with a list of all the households that they will also be giving that information to. So that's how you create common knowledge in this case, right? I'm sorry that's probably more long-winded and crazy, but this was our way to make sure that we do the best we can with the data. And am I missing out on anything critical at this stage?
No, essentially we're trying to bypass any network failure. So what we're trying to exogenously vary is the percentage of your network who is actually going to be attending with these extra incentives.
Well, I haven't said anything about the incentives yet.
Right, okay, with these extra visits,
Yeah.
the percentage of your network who is receiving the information, but we can't detect that effect if I don't ever find out that you received it. And so with the common
Right.
knowledge, then we're making
Right.
sure that I know who in my network is receiving it.
Which relates to a point earlier that Jim had made, is that if we don't introduce this common knowledge exogenously, in this setting, it's entirely possible that the information sharing that's happening could be completely endogenous. Right? We might learn that some groups have shared more information versus others. That's because Kendall has a really nice network of people. I know 10 people, but we don't really talk all that much. Right? We have that node which says whom do I talk to? How much do I talk to them? How much information do I share? What quality of information? We don't know that. So with common knowledge, we can relax some of those assumptions and actually do a little better. In some sense, we are enforcing that. Not only that I know that Kendall is going, but I make sure that Kendall knows that I know that she's going, right? Or at least close to that. Go ahead.
Just out of curiosity, have you considered telling them that non-friends are going?
No, we have not. That's an interesting one. I have not.
You're not doing enough already.
Well, I don't know if we can still pull this off. I'll come back in 2 months and tell you how badly it bombed. But that's so far that's what we are doing. The second thing is, so far information, like we mentioned, information transfer could still be endogenous to the sort of underlying structure of networks or some characteristic of networks that we cannot really fully observe. And so one thing that we are trying to do in that space is to introduce incentives. And the idea is to be able to more precisely answer that question, what's the effect of participation in my network within my network on my own decision to participate. So what we do is a subset of these households, the ADA here, receive a small incentive to participate in the program. And truth to be told, we are still figuring out how to introduce this incentive without violating all the exclusion restrictions and stuff. It's less than straightforward. But the idea is if we can incentivize a small subset of each network to participate, and that share is varied across the networks, then we'll be able to estimate what the effect of 10% of my household, my network participating is relative to say 50% of my network participating in these meetings. Because we can now exogenously, using incentives, change what share of my network relative to Kendall's network shows up for these meetings. I think that was main part of it. The one thing I wanted to point out to you, so far I've just been sort of referring to picking X% of a network as if it was fairly straightforward. Turns out it's not that straightforward. Because if you think about what I just described, I said I will pick some percentage of households in a network and expect that to create variation in what shares of, erase that, let me go back one more. I'll pick some share of households in a village, and that number is going to create exogenous variation in shares of networks within the village that are going to be either visited or incentivized, right? But the problem is, given the strength of networks that vary widely across these networks, and you just saw 2 examples, it's not so straightforward what that would look like. So what Jim did was, he took all of this data, and Jim, you should correct me if I'm wrong. I'm only showing you the random sampling method. There were multiple different methods that Jim used. And we started with 0 to 10, 10 to 20, 20 to 30, 30 to 40% % of households being sampled randomly. And then this tells you what's the likelihood of one of my neighbors being sampled as at least one of my neighbors from my network being sampled into the network as well. So what we eventually decided was we'll have around 35%. If we sort of, on average, if we pick around 35% of households in the villages to be sampled, then we'll get a fairly good distribution on the low end and the high end as well. So do you want to add to that? Or?
Yeah, I think that there's a couple of fun pieces here. If I remember right, that's what these columns are, the different distribution.
Yep.
This is like 10% sampled and like 40% sampled.
That's right. That's exactly right.
I remember this piece.
Yeah.
And so the thought was, if you randomly sample a small proportion of the population, most of the people will not have any of their neighbors in the network. If you sample a heavy percent of the population, a few people will have none, but a few people will have everybody, 100% of their neighbors will be in the network, but you'll get some variation to the through.
Right.
But this is really expensive. This is really cheap, and so the thought is, what spot can you find here where you get enough variability to get some people with zero, some people with all of their neighbors in the network, but not spend a bunch of money you don't need to spend out here. It's actually kind of a fun little sampling problem, and so it turns out that on the one hand, random sampling it has all the advantage of being easy to describe in interviews. You have to train it, these kind of things. But because I couldn't help myself, there's a bunch of other ways you can imagine sampling as well. So you can sample central people or not central people. My favorite that Manoj won't do is but I'm going to tell it to you anyway because hopefully one of you will do it someday. Is an adaptive sampling process where if I want to maximize the spread of information, I pick Giovanna. Giovanna tells me who her friends are, and then I don't pick any of them. I pick somebody else, right? Because I'm going to count on Giovanna to inform those neighbors, right? So I find somebody who's not, and they adapt. And so you can imagine essentially a backwards RDS, where what I want to do is maximally cover the network without actually having to sample the network, and you can do that. You can get a maximal coverage. And the problem with that is you'll actually end up with bulk over here instead of over here. Because I misunderstood his question, I had to do that first. So this random sampling is actually a very efficient way with a certain number to get a nice variability in the exogenous exposure. But if you ever have the question where what you want to do is optimize your message people, then it turns out, have a strategy for doing that as well.
Yeah. And part of the reason why we push back hard is that if it was going to be hard enough for Jim to explain to us, imagine us having to write that down in a paper and explain to the audience why we did not just do a random sample. But someday we'll get there. Someday we will. All right, so then the rest of the stuff is just around information analysis plans we'll do, which is really not all that helpful because it's what we're going to be doing. And once we do it, then it'll become more useful. This is stuff around calls that we'll be making to households and, a bunch of institutions, including the state government, the World Bank, gave us tons of money to play with. So thanks to all of them. And I'll stop there, and if there's any other questions, I'll take them. Please. Caste issues and politics issues and religion issues and poverty. Yes. Designed in terms of
thinking about who's influential in the neighborhood data, who's in the networks, who goes to the meetings,
Yeah.
cell phones, access,
So, two things. One is that for better or for worse, cell phone penetration in these markets, even in rural areas, has become wide enough that it helps us quite a bit. But it doesn't solve all the problems because the people who are at the tail end of the distributions are the ones who will not have phones, even though the average number of phones in a household, conditional on having one, is about 1.7, 1.8 or so at this point, right? So your question is absolutely right. So one of the things that we do is we rely on the cell phone based stuff to measure what's happening in terms of our rapid response data collection, but a lot of data is also being collected during these monthly meetings. So one of the cool things that the state has developed, and actually I should give credit to them, is at every meeting they've developed something they call it a phablet. I've never heard it before. It's basically a phone-based tablet device. Think of it as a nice Samsung big device, except it's really cheap. And the only thing it does is it takes a nice panoramic picture in high definition and transmits it immediately to their server. So at every meeting, they basically take a picture, and that basically helps them identify how many people were there and who was there at the meeting. So we'll be using that to try to triangulate with our own information about who's there. That's one part. And the second is, what I've not told you about is all the follow-up data collection at the household level, where we then go house to house to try to get that. But yeah, it is a challenging environment. It's far from easy in that case. Yeah. Go ahead.
So just a clarification question, is your common knowledge idea similar to the complex confusion? So the proportion of people in your networks who will go to these meetings will decide your probability to go, or at least that's what you're trying to find out.
I think yes. I think that's right. I mean, but I think with common knowledge, what we are trying to do is that if we want to make sure that if you and I are making this decision independently, we both want to make sure that you and I have the same information, right? So if there is a party happening and I'm going to go there, based on whether you are going to go or my guess about whether you're going to go, I need to know that you know, and you need to know that I know that that party happens, right? That's the common knowledge we are trying to
I
establish.
think there's a slight technical difference between this and the complex diffusion. So
Right.
the one side is that in this case, the complex diffusion model, it doesn't assume common knowledge. So it's the case that it's really just an SIS kind of model. So I have the bit, my friend has the bit, and so the third party has some probability of getting the bit. In this case, this is short-circuiting that probability. It's saying, all right, now I know you have the bit. Do I adopt it or not? And so it centers the question on the adoption side.
Yeah.
The other element that's a little bit different is that the independent exogenous thing we're trying to maximize variability on here is the proportion of your peers that are getting the visit or not, as opposed to just the number of your peers.
Right.
So if I have one friend and it's 100% of my peers get it, that's different than requiring at least two of my friends do it or something. Now these data at the end, when the analysis comes through, you could just as easily run it on the number of friends, but in order to get variability across the entire population, in the proportion of set, people have a lot of friends. To get 80% of somebody who has 10 friends, 8 of their friends are going to go. So it's going to be it's an open question, I think, at this point, whether it's going to be the number of the proportion that actually drives the result.
Right. And actually, just to add to that, to think about what we will be doing with this data eventually, we want to ask about possible threshold effects or free riding that might happen that's different across subgroups. So most of you in the room know that there are many of these networks that we observe in villages are fairly segregated by caste and religion often. And so it would be very interesting to ask if, do we see very different threshold effects for participation in a lower caste versus in a higher caste where you don't see those kinds of threshold effects, and that will have very big implications for how we think about developing these collective action types of policies and interventions.
Do I understand you correctly that for the broadcasting it's purely cell phone announcement, and then for the visit it's visit, right?
Right. So almost. But please go ahead with your question, and I'll come.
No, I was like, if that's true, then in your spare time you might look at the different channel because we're IS people. So
Yes.
It's a technology-wise, and then like in face-to-face. So if you tell me that you already told Jim that about that meeting,
Right.
after you're gone, I might call Jim and say, hey,
Yep.
you hear about this?
Right.
We're going to confirm.
We could. So our goals are a little more modest. So let me answer that in two parts. For the broadcast stuff, we call people and we tell each individual person receives at least a phone call once, or probably a phone call followed by IVR type of stuff that's happening repeatedly. The part that you mentioned, what we are trying to do, it's not exactly what you said, is after I've given you information, end of the month, I call your friend Jim, who was not given information, and ask him what he knows about the message. Right? Now, we can't figure out if you spoke to Jim or if Kendall spoke to Jim or Giovanna spoke. He could have got it from anywhere. All I know is he was called or he was not called and what he recalls from there, which is not as satisfying as what you said. But otherwise, because it's not a one-to-one network, right? Each individual knows so many other people. We'll have to rely on their recall of who told you about this, and we didn't. I mean, all of this is still retrofitting as proactive as this sounds, trust me, this was all stuff that we realized could be done after we had already got this ball in motion. So, yeah. Sorry, I don't have a better answer.
It's great. It's just like we always see things from the technology
Yeah.
perspective.
Can you speak just a moment to sort of what you have to do in terms of privacy, IRB, these kinds of issues to pull? I mean, because you've done now a network study in 80 villages, 400 people in each. I mean, so this is from a privacy standpoint, a huge.
Yeah.
Like, so can you just give us any insights to your IRB process and the rest of this?
So first, Chatham House rules apply, right? No, I'm just joking. We did have to take care because we were collecting not just data. We will be collecting not just data on people with cell phone data as well, which is part of standard identifying procedure. But we'll be working with it. So what we did was we put layers of protection in there. We also this is a state-sponsored project working with the state government. So India has a very peculiar set of IRB regulations and restrictions around these types of projects. If it's a project that gets funded through multilateral aid, not bilateral aid, but multilateral aid, with a state government, then the requirements around India's legal requirements around IRB are very different. So we do have our data collection teams go through IRB and stuff, but the state government can pretty much establish any project that they want in this case, right? So the IRB requirements for our project are really about data collection, data management. And so what we've done is we essentially have a link file that links household IDs, the numbers that you see, to the phone numbers and the identifiable data sets, which are split across two of our research teams. The team that collects the network data is different from the team that sends out the cell phone information. And then only as of 48 hours ago, we gave them permission to actually talk to each other about sharing that information. So right until the time it's ready to go, we didn't share that. And Kendall and we will never see the identifiable information. They'll send us a blinded data set which has only household ID numbers that we looked at. It's still, if this were an NIH-funded project in the US, you probably still would run into a lot of trouble with that. But that's just the nature of the beast. Yeah. Awesome. All right. Thank you very much.
Thank you.